Hello, and welcome to the Student Workshop. My name is Alex, and this is my first SAT Math video. I'm going to be going through today how to do the hardest SAT Math questions as picked by me from the 8 full-length practice tests on the College Board website. These are based on how difficult they are, as well as the ones that most of my students struggle with. There are 28 of them. So let's get started. You can see the link here is from the collegereadiness.collegeboard.org. And just to say before, I highly recommend that you try these problems before I do them. Give yourself a shot. Take a look at what you can gather from the question, anything that you can kind of figure out from the equation or what the problem is asking for before you watch me do it. Will be at least good practice. But without further ado, we have question number 7 on the no calculator from the first test. We have this pretty nasty looking equation, and then the formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months. Which of the following gives P in terms of M, R, and N? Now, most of this isn't super important. We don't really care what P, M, R, or N stand for. What we care about is giving P in terms of M, R, and N. And if you're not sure what that means, you can take a look at some of the answers and maybe get an idea. The original equation has M equals the rest of this scary looking stuff, and all the answers have P equals. So essentially all we're trying to do is isolate P in this equation, and in order to do that, we can do some algebra. Now if we had an equation like M equals A times B over C times P, this wouldn't be too difficult. What we want to do is move everything on P side over to M side, so we can multiply by the denominator and the numerator, so it cancels itself, so C's would cancel, and then we just divide by what's in the numerator, so the A's and B's cancel. It's all multiplication, so it's all simple. A over A equals 1, B over B equals 1, so it doesn't actually affect P anymore. But we have to do that same thing on M's side, and we just get P equals CM over AB. And our equation actually isn't much more difficult than that. As you can see, anything that started in the numerator ended up in the denominator, and the thing that started in the denominator ended up in the numerator. So that's all we have to do with our equation, is just take everything in the numerator, since it's all being multiplied, and bring it to the denominator, and everything in the denominator we can multiply and put it in the numerator. And if you look closely, you can see that that's exactly the case in answer B. And that's our answer. All right. Next one we're going to look at is number 14 in the same test, no calculator. All right. It says if 3x minus y equals 12, what is the value of 8 to the x over 2 to the y? Now, you might be asking yourself, we only have one equation and two variables. How could we solve for both of them? There's a couple things you can do with a problem like this. It's important to note that the fraction that we're trying to find the value of has different bases, and both being raised to exponents. And in order to simplify a fraction with exponents, we need to have the same base. So that's going to be our first step, is to take 8 to the x over 2 to the y and give them the same base. Now I can see that 8 is the same thing as 2 cubed, so I'm going to substitute 2 cubed in for 8. You get 2 cubed to the x over 2 to the y. Now anything raised to the power and then raised to a power again, what we can do is just multiply those exponents. So we get 2 to the 3x over 2y. And then this is an exponential in base rule. We can take any, let's say we had 4 would be a bad example. say we had 5 to the a over 5 to the b, that would be the same as 5 over a minus b. So we subtract the numerator's exponent and the denominator's exponent. Now if they were being multiplied, just for another look at different exponential rules, we actually add those exponents. So it'd be 5 to the a plus b. So you can see that we have division here. So what we're going to do is subtract our exponents. And maybe you noticed that that 3x minus y is what we were given in the initial part of the question. And that's just equal to 12. So 2 to the 12. And all that simplification ended up giving us an answer. A equals 2 to the 12th. And that's kind of what you just have to do for these types of problems, is look at what equations they're giving you and the expression that you're trying to find the value of, and just doing some exponential trickery to try and get it to look like something in the answers. It's kind of a keep doing things until you find something that works. All right, it's going to be the last one from the no calculator, but we do have a couple in the calculator section. Question 20 is the next one. Great. So Alma bought a laptop computer at a store that gave a 20% discount off its original price. The total amount she paid to the cashier was P dollars, including an 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? Well, there's that finding something in terms of something else again. Now what I'm going to do is try and set up the original idea. Instead of trying to guess at which answer makes the most sense, I'm going to set up the original equation based on the price of the what was it, a computer? Yeah, a laptop. And then what manipulation is happening from the discount and the tax, and see how that affects the ending price. So I'm going to say the original price is just OP, and that had a 20% discount on it. So we can represent that by multiplying by 0.8, which is essentially just 1 minus 0.2 times OP, which, if we distribute the OP, is the original price minus 20% off the original price. So that's where I got the 0.8 from. And then that has a percent sales tax. Now when we're doing discounts, we do 1 minus the percentage. In taxes or percent increases, we do 1 plus, so we get 1.08, and that equals the final price. And now, just like we did in question 7, in order to get the original price by itself or in terms of P, we just divide by what's being multiplied by it. So those both cancel, and we're just going to end up with OP equals P over 0.8 times 1.08, which is that one right there. So no guessing necessary. If we set up that original equation, we can do pretty simple algebra and get our answer. All right, last one for this test is 29, and this is a great question. I really like this one. So for a polynomial p of x, the value of p of 3 is -2. Which of the following must be true about p of x? Now, I definitely recommend taking a look at this one, trying to figure out what the differences are in the answers, and which one, maybe even looking at which ones don't have to be true, right? Because this one says which of the following must be true, and that's pretty important for this question. We need things that will always be true, no matter what our polynomial function is. So what do we know about p of x? Not much. What we know is that p of 3 is -2, so at a point, it has this point in it, 3, -2. Now, if we look at these different answers, 3 of them say there's some factor of p of x. Now, what that means is that if x minus 5 is a factor, that means there is an x-intercept at the value that would make that equal to 0. So there would be a x-intercept at x equals 5, so we'd have the point 50. Now, what I usually go through with my students is, can you think of a polynomial that goes through 3 comma negative 2, but does not go through 5 comma 0? And there's an infinite number of them, right? A really wide parabola going this way, a straight line going that way, not very straight, some sort of narrow cubic. There's an infinite number of functions that go through 3, negative 2, but do not go through 5 comma 0, so they do not have that as a factor. And that's actually true for A, B, and C. And we'll actually draw a parabola that has no factors, or no at least real number factors. And that's what we're going to use to actually explain why D is in fact the correct answer. So this parabola, we know the vertex, we know it's facing down, so we can write P of x equals negative x minus 3 squared minus 2. And if you don't know where I got that formula from, it'd be good to check in on parabolas and vertex form in particular. Now what I'm going to do is expand that into negative x squared minus 6x plus 9 minus 2. So we end up getting, write it down here, px equals negative x squared plus 6x minus 9 minus 2 is minus 11. Great, so that's our made up p of x. Could have been anything, but I wanted to look at it this way just to show that even though it has no factors, we will actually have the remainder when p of x is divided by x minus 3 is equal to 2, negative 2. So we'll check for the remainder when we divide it by x minus 3. And I like to use polynomial long division, but you can use synthetic division if you like that better. 6x 11 divided by x minus 3. All right, so to get x to negative x squared, we need to multiply by negative x. That gives us negative x squared plus 3x. We subtract just like regular division, and that goes to 0, and we get 3x minus 11. And now, in order to get x to 3x, we need to multiply by positive 3. So we get 3x minus 9. And when we subtract those, we get negative 2 as our remainder. So just put plus negative 2 over x minus 3. And this comes from negative x squared plus 6x over x minus 3. And that is going to be equal to negative x plus 3 minus 2 over x minus 3. Now this setup, and maybe you are thinking that I picked that polynomial because that one specifically has negative 2 as a remainder when I divide it by x minus 3, but I will show you in more general terms why this is always true. So let's take a p of x, and we'll divide it by, let's say, just some factor. A represents any number, any constant. Could be 3, could be negative 100. And as you saw when we did that division, we ended up with some other polynomial. In our other one, it was negative x plus 3. And then it was plus the remainder over what we divided the original polynomial by, p of x. Now what we can do here is multiply both sides by x minus a. And that's going to cancel on this side, so p of x. And then we distribute the x minus a into the q of x and the remainder fraction. So we get q of x times x minus a, and those cancel, plus r. And now in order to make it similar to our problem, we're going to say that we're going to pick p of a, right? Because we divided by x minus 3 and it gave us p of 3. So we want a, the function, the number that we're putting into the function, equal to the y value. So the x value in this case would be a. So p of a equals q of a times a minus a plus r. Now we don't care what q of a is, could be anything. What we do care about is that a minus a equals 0, so this times 0 also goes to 0, and we end up with P of A being equal to R. And so any polynomial that when you divide it by x minus some number, is the remainder is going to give you the actual value at that number, the y value at that number. And those are the hardest from the first practice test. So let's move on to the second one. And this is actually practice test 3. The College Board removed tests 2 and 4 and put in tests 9 and 10. I'm not sure why. I actually really liked test 2, but it is what it is. Next one is y equals a, or this is number 12 on practice test 3, no calculator. We have y equals a times x minus 2 times x plus 4. The graph of the equation in the xy plane is a parabola with vertex CD, which of the following is equal to D. All right. So where to even begin with this one? Well, we can see that we have a quadratic, right? We have an x minus 2, x plus 4. It's in x-intercept form, and the intercepts are 2 and negative 4, so that's important. We'll put that in. And this is where I was talking about trying to just recognize a function and identifying what you know about the function before trying to dive in to what the problem is. And then it is a problem with vertex C comma D, which of the following is equal to D. So our vertex is C comma D. One thing that's very important for this problem, as well as some other problems, is that the vertex lies halfway between both x-intercepts because parabolas are symmetrical. So since we have an x-intercept at x of 2, 0 and negative 4, 0, the average of those being negative 1, our vertex is going to lie somewhere along that line. And that's supposed to be a parenthesis. So we in fact already know that C equals 1 because that's the x value of our vertex. So we have a point 1 comma D, and a lot of times you'll be given points in functions. This one was a little harder to find than other ones, which is why I consider this one of the hardest questions in these 8 tests. And we're going to use this point now to plug it into the equation it gives us and try and solve for D. So D is the y value equals a times 1 minus 2 times, negative 1. That would have been bad. Negative 1 plus 4. And that's going to be D equals a times negative 3 times 3. And so D equals 9a. Negative 9a. Don't forget your negative signs. Great. So, this sort of problem, again, we're given D and we're given that all the answers are in some form of A, so I knew at some point I would have to substitute in D and out something else, but in order to not have C in that equation, I had to figure out what C was, and that's why I used the x-intercepts and the fact that the vertex is going to be the average of those two, or just halfway between. All right. Next one is 20. All right, in triangle ABC, the measure of B is 90 degrees. Okay, anytime I'm given geometry on the SAT, I immediately start drawing because it's helpful to keep things in check. So we have triangle ABC, and B is the right angle. So A, B, C with the right angle B. BC is 16, AC is 20, and this is a good kind of thing to keep an eye on in the SAT. There are 2 Pythagorean triples that come up a lot, and that is a 3, 4, 5 and a 5, 12, 13, as well as all families of those, any multiplication or division of all of those numbers. And I can see right away that this is a 4 times multiplication of the 3, 4, 5 family Pythagorean triple, so I'm going to put 12 in there without having to do the whole Pythagorean theorem. It can save a lot of time if you're familiar with those Pythagorean triples. All right, triangle DEF is similar to triangle ABC, so let's make sure we label it correctly. DEF, that's our right angle. And each side of triangle DEF is 1/3 the length of corresponding side of triangle ABC. What is the value of sine of F? Now, I could go through and divide each of these by 3, and then do sine, which is opposite over hypotenuse. But since they're similar, I actually know that F and C are the same angle. And so the sine of F is going to be equal to the sine of C. And even beyond that, if I were to draw the actual 3, 4, 5 right triangle, where I know it looks like 4 is smaller than 3, but that's not super important. I'll know that this angle that's corresponding to C and F is going to be the same angle, because all Pythagorean triples are similar to each other, or all the families are. So if I know the sine of, let's say we have XYZ, the sine of X is going to be equal to sine of F and sine of C. So I do the sine of X, I know it's opposite over hypotenuse, so that's just 3/5. And that'll be the same for the sine of C and the sine of F, as well as any other Pythagorean triple of the 3, 4, 5 family that's in that corner. Great, so that one's 3/5. We're done with the no calculator, test 3. Couple in the calculator section. Let's go find those. First one is 27. All right, great. This is a tough one. Not like the other were a breeze. But a rectangle is altered by increasing its length by 10% and decreasing its width by p%. If these alterations decrease the area of the rectangle by 12%, what is the value of p? All right, so with these alteration questions, we're going to look at the original expression and then what alterations were made, and then see how it compares. So I know I'm dealing with length, width, and area, so the original one is length times width equals area. Excuse me. These, and then it was altered. The length was increased by 10%. So we already talked about how that's just 1 plus the percentage times L. Decreasing its width by p%. All right, that's a little bit harder to represent, but if we do 100 minus p over 100 times W, if you look at that, you can see that we're taking, in other words, we could say 1 minus p%, so 1 minus 100 times W, but in this case, I think it's going to be easier to deal with the hundreds and not the split fraction. But yeah, we're subtracting essentially p%, so we need to divide it by 100, and that's something that the SAT kind of throws in and makes a little complicated. We're not dealing with, let's say, p was 50%. We're not dealing with p being equal to 0.5. We're actually dealing with p being equal to 50, because it is that percentage. So you have to be careful with that. But then that is equal to the area being decreased by 12%. So that ends up being 0.88 A. Now A, we know, is equal to L times W. So 1.1 L times 100 minus P over 100. W equals 0.88 L times W. And now we just care about P, so I'm going to cancel out these L's, and we're going to use this W and this W and see what is being altered in order to get this 12% decrease on A. And that's just going to be a little bit of algebra. So 1.1 times 100 minus P over 100. W equals 0.88 W. And I'll just put, this is the original W and this is the new W. So if we multiply both sides by 100, we get 1.1 times 100 is P. Actually, you know what? That's kind of confusing. They're the same W. We just want to see what P would equal. Equals 88 W. And now we can divide by 1.1 to both sides. 100 minus P W equals 88 divided by 1.1. 1.1 is just 11 over 10. So if we multiply by 10 over 11, that's the same thing as dividing by 1.1. So 88 divided by 11 is 8, times 10 is 80, so 80W. And we can see that 100 minus P has to equal 80 for that alteration to equal this alteration initially to equal the 12% decrease on the area. So the P has to equal 20. All right. Next one is 36. Okay. In the xy plane, if a point with coordinates a, b lies in the solution set of the system of inequalities above, what is the maximum possible value of b? All right. We could do this one algebraically, but I found this one easier, especially most systems of inequalities, to do it graphically. So we'll look at y is less than or equal to 5x, which looks like that. Less than or equal to means the y values are below the equation of the line, and then we'll draw this one in red. And we're going to be up 3,000 and then negative 15x. So this is also something important. Be really comfortable with drawing lines. It makes it a lot easier to do some of these problems. Be familiar with graphing. How to do that, and then we'll make that red, and everything in the middle is purple. So the purple area is the thing that satisfies both inequalities, and we're going to be looking for the maximum possible value of b, which luckily enough is just the intersection point of those two. So we can actually change these now to just equal signs because we're trying to solve for the intersection. In order to do that, we can set them equal to each other. Add 15x, 20x equals 3,000, so x equals 150. And now we're looking for the b value, which is in the y position. So we can just do y equals 5 times 150, and y equals 750. And that would be our answer. All right, 2 tests down. All right, this one is test number 5. Remember, tests 2 and 4 were removed. And we're going to be doing number 15. Let's give ourselves a little bit more space to work. Alan drives an average of 100 miles each week. His car can travel an average of 25 miles per gallon of gasoline. Alan would like to reduce his weekly expenditure on gasoline by $5. Assuming gasoline costs $4 per gallon, which equation can Alan use to determine how many fewer average miles M he should drive each week? All right, so we're trying to get to a reduction of his weekly expenditure on gasoline by $5. So we're trying to solve for the miles reduced that will give us $5. So we're solving for $5. And when I'm dealing with rates, such as miles per gallon or dollars per gallon, I really like using dimensional analysis, which if any of you have taken chemistry will be pretty familiar with. But essentially it's just a separation of the units and the values in order to solve for something. And I can see that my units in the end need to be dollars. And we're using M miles. So I'm going to find dollars per gallon. That'll be good. We'll start with that. $4 per 1 gallon. Now I need something to get rid of gallons, and that will be in miles per gallon. He travels 25 miles per gallon of gasoline. So 1 gallon, 25 miles. And I wrote the rate upside down in order to get rid of the gallons. And now I need to get rid of miles. And what they're saying is that he wants to solve for m, so this equation has to include m miles, and that's not a ratio, so we just go over 1. Miles cancels, and we're left with just dollars, and we have 4/25. M equals 5, both resulting in dollars. So D would be our answer for that one. It's a little difficult to even set up that equation. That's why I really like using dimensional analysis, and really you need an end goal in mind for at least units wise in order to determine what how you're going to set that up. All right, next one is number 15 in the calculator section. A little bit further. Okay. This isn't a regular math question. The SAT involves some of these survey questions, so we'll give it a read. Polling agency recently surveyed 1,000 adults who were selected at random from a large city and asked each of the adults, "Are you satisfied with the quality of air in the city?" Of those surveyed, 78% responded that they were satisfied with the quality of air in the city. Based on the results of the survey, which of the following statements must be true? All right, we'll go down these one by one. Of all adults in the city, and again, keep an eye out for this must be true. That's pretty important. Of all adults in the city, 78% are satisfied with the quality of air in the city. Now, they surveyed 1,000, which is a pretty good statistical number. However, it's only an estimate, so it's not absolutely true that 78% on the dot are satisfied. It could be a good estimate. You might have found a group of 1,000 adults that really liked the quality of the air, so it might be actually a bad estimate. You don't know it. Or it could be they had some grumpy people that were being surveyed, and the actual amount is closer to 85%. You can't know, and so that doesn't have to be true. All right. If another 1,000 adults selected at random from the city were surveyed, 78% of them would report that they are satisfied with the quality of air in the city. Similar thing. You could get a really grumpy group, or you could get a really happy group. And you really, in these statistics ones, you want to think on absolute extremes, because they're saying which one must be true. And that one definitely does not have to be true. We don't know. You would have to get the same 1,000 adults to be sure that it would be true. And they're saying they did it randomly, so that would not work. Number 3, if 1,000 adults selected at random from a different city were surveyed, 78% of them would report they are satisfied with the quality of air in the city. That's a totally different question. You have no idea. It could be, you're comparing apples and oranges at that point. So it might be true, but it definitely doesn't have to be true. So none of those. And that's kind of why I picked this one, because it can be confusing to eliminate all of those, and you don't usually want to pick none, but really just go one at a time with these and really make sure that if they're saying it must be true, it really must be true. Let's get rid of some of those, give myself some more space. All right, test number 6. We're going with number 13. All right, 2x squared minus 4x equals t. In the equation above, t is a constant. If the equation has no real solutions, which of the following could be the value of t? All right, no real solutions for a quadratic means that if we set it equal to 0, then it would never intersect the x-axis, which, if you're familiar with the quadratic formula, all we care about here is the discriminant being less than 0. If it's equal to 0, then there's one solution, and if it's greater than 0, it's 2 solutions, because we have that opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This plus or minus, if the discriminant, which is the part inside the square root, is greater than 0, then we'll both be adding and subtracting that value from negative b. If it's equal to 0, then it doesn't matter if we add or subtract it, we'll just get the same value. If it's less than 0, we'll get 2 non-real solutions, and it's asking for real solutions. Because if we take the square root of a negative, we get something with I in it, so it's non-real. So we want this to be less than 0, and this is when we set it equal to 0, at least our quadratic, so we have to move this t over, set it equal to 0. We can see that a is 2, b is -4, and c is -t. So we can get -4 squared minus 4 times 2 times -t must be less than 0. 16 minus plus 8t less than 0. 8t must be less than -16. So t must be less than -2. And that's the only one that's less than -2. So -3 is our answer. There's another way to get this, and I like looking at this graphically. Some people, that algebraic stuff might be enough for you. But if you like looking at things graphically, we can treat these as two separate functions. Again, we have a quadratic in 2x squared minus 4x, and we have t. And when we set them equal to each other, we're essentially looking for their intersection points. But if we want them to have no solutions, then all we're looking for is them to never intersect. And since y equals t, and t is a constant, that means it's just going to be a horizontal line. Well, we can look for some values where the horizontal lines would not intersect with our parabola. So the important thing is to be able to graph this parabola. So get this into intercept form. So y factor out of 2x, x minus 2. So our intercepts are 0 and 2. And like I said before, the vertex is going to be halfway between those, so at 1. And we can figure out what the y value is by plugging 1 into our function. 2 times 1 squared is 2, minus 4 times 1, 2 minus 4 is -2. So we get something that looks like that. Always worse at drawing the left side of my parabolas. But you get the idea. So we have this point 1, -2, where if any horizontal line was below that point, we would have no intersection points. And we end up getting the exact same inequality that we did by solving for it using the discriminant and setting it less than 0. So graphically, algebraically, you get the same answer. This one is A. All right, next one is 19. All right, how many liters of a 25% saline solution must be added to 3 liters of a 10% saline solution to obtain a 15% saline solution? All right, this is a word problem. There are some similar word problems that are definitely not as hard as this one because it's not obvious that this one you need a system of equations, but this is definitely a system of equations question. And the first thing to do with systems of equation questions is identify your variables. So x is going to be my 25% saline in liters. Y is going to be my 10% solution in liters. And z is going to be my 15% solution in liters. And it might seem evident that we'd have to set up one of the equations like this, where move this over so I can actually write it, 0.25 times x plus 0.1 times y equals 0.15 times z. That's giving essentially the amount of saline, right? We're finding the percent of saline times the liters, because x, y, and z are all representative of the liters. So that will give us our equation for the amount of saline. But just as important of an equation, we need x plus y is equal to z. And that's that our initial solution plus our secondary solution will equal the final solution in liters as well as saline amount. Now that's 3 variables and only 2 equations, so we need to look for our third equation, and that one's just going to be snuck in there as there are 3 liters of 10% saline solution, so y is equal to 3. And now we're solving for 25% saline, so we're trying to solve for x, so let's get rid of the other variables. We know x plus 3 equals z. So z equals x plus 3, we can substitute that in, and we can substitute 3 in for y, and then we just have one equation with one variable, the one we care about, and that's what we're looking for. So 0.25x plus 0.3 times 0.1 times 3 is just 0.3 equals 0.15 times x plus 3, and then we do some algebra. And I give my voice a break. Subtract the 0.3 over, subtract the 0.15x over, we get 0.1x equals 0.15. Multiply by 10, x equals 1.5. Right, and that's a much tougher word problem in system of equations, but the important thing is setting up your variables and identifying what your different equations are, because the algebra after that is not too bad. All right, we are on to 6. Okay, so 7 is your next one in the calculator section, and that is right here. All right. So 2x squared minus, an xy plane, the graph of 2x squared minus 6x plus 2y squared plus 2y equals 45 is a circle. What is the radius of the circle? All right, so if you're not familiar with an equation of a circle, in order to find the radius, we need to set it up in x minus h squared plus y minus k squared equals r squared. And if you have trouble remembering this formula, it's very similar to the Pythagorean theorem, where we have the location on the circle plus the other location is equal to the radius, because we can all find that using triangles right triangles in a circle. Try it out for yourself if you haven't seen that before. And this is where h comma k is our center, and our radius is r. So hk is our center, radius is r. And so we care about finding r. But it's also important that we actually get it in this form, because otherwise this value is not actually r squared until we get it like this. So in order to do that, we're going to complete the square twice. Now, completing the square, I like to do with nothing in front of my x or y squared pieces. So I'm going to divide by 2 across the whole thing right off the bat in order to get that out of there. Now it will cause me to do some more fraction addition, but that's much easier than dealing with some a value in our x squared. Now completing the square, what we do is divide by 2 from our x or y, the one that's not squared, and then square it and add it in. But we have x minus 3 halves. That becomes the x value of our center. And this one's going to have y plus 1/2 squared. Now, how that affects our equation is that if we were to extend this out, expand our x minus 3/2 squared, we're going to end up getting x squared minus 3x plus 9/4. And this plus 9/4 is new to our equation, so in order to balance that out, we have to add it in on our other side, because we don't want to change what we're actually dealing with. So we added our plus 9/4 in order to make this have our the x value of our center look like that, and so we have to add it in on the other side in order to balance our equation. Same thing for our y. We end up with y squared plus y, but we also added in a 1/4, so we have to add in a 1/4 over here. Now all we have to do is figure out what 45 halves plus 9/4 plus 1/4 is. I'm going to give it a common denominator of 4, so 90/4 plus 10/4 is 100/4, which is just 25, and that is going to be our r squared, so r must be 5, which is A. Awesome. All right, that's it for that test. let's move on to test number 7. We're going to start with, get me back in position, start with number 14. All right, a shipping service restricts the dimensions of the boxes it will ship for a certain type of service. The restriction states that for boxes shaped like rectangular prisms, the sum of the perimeter of the base of the box and the height of the box cannot exceed 130 inches. All right, I'm just going to, so I don't forget what I just read, draw a little box and show, let's say, width, length, and height. The perimeter of the base, which is 2W plus 2L, plus the height can't be bigger than 130. So, in other words, less than or equal to. All right, that's telling me what I just said. If a box has a height of 60 inches and its length is 2.5 times the width, which inequality shows the allowable width. All right, so height equals 60, length equals 2.5 times the width. What width are we allowed? We can just substitute those in. 2W, 2 times 2.5 is 5, so 5W plus 60 is less than or equal to 130. And then we subtract 60 and combine our W's. So W has to be less than or equal to 10. All right, in other words, X. I was using W. They say X. That's fine. Also, it has to be greater than 0. Otherwise, it would be a interdimensional box without any width, which wouldn't make any sense. So that's why they have that greater than 0, because all lengths have some value, can't be negative. All right, that one wasn't too bad, but I did want no calculator, at least for part of this test. None of the rest of the questions were too challenging. But when we move to the calculator section, we have a couple. Looking for 25. All right. So we have this table. It says energy per gram of typical macronutrients, and then we have proteins, fats, carbohydrates, and we have food calories and kilojoules. All right. If X food calories is equivalent to K kilojoules of the following, which best represents the relationship between X and K? So we're just looking at the relationship between food calories and kilojoules. And you can use your calculator on this one. I can see that we have some sort of linear relationship between the two based on the answers were given. And I can see that food calories is definitely being multiplied by something to get to kilojoules, and that's approximately 4.2. So I'm going to make sure that I have this in the right order, and I'm going to say it's K equals 4.2x. Great. That one's B. That one is not the hard one in this group, but I did want to do that one first. Now we have to look at 26. If the 180 food calories in a granola bar come entirely from P grams of protein, F grams of fat, and C grams of carbohydrate, which of the following expresses F in terms of P and C? And we have 4 answers that look very similar with only slight differences. So the important thing here is setting up our equation and making sure we do all the algebra very strictly. Now we have 180 calories is equal to, it comes from P grams of protein. Now we have this ratio above that says that for each gram of, it's energy per gram. So the amount of calories per gram, which is going to be very important for converting our grams of protein, fat, and carbohydrate into calories. So we have P grams of protein, and we're going to multiply that by 4, and this is going to be, just to show you units, at least on this one, it's calories per gram of protein, and this is P is in grams of protein. So it does check out that when we cancel out our grams of protein, we are left with just calories. And since we can only add calories to other calories and equal calories, that's good. And I'm just going to rewrite this so it's not P4, it's 4P. And from the table, I know we have 9F and 4C. And those all came from the table. And now what we have to do is isolate F. The hard part, I think, is just getting this equation set up. And I think recognizing those units, what units you're given and what unit you're trying to get to. You're given 3 different types of grams of macronutrient, and you're trying to convert it to calories, which is energy. And you do have to use that table in order to make those conversions. And now to isolate F, we can subtract 4P and 4C, and I'm going to jump down here so I have more room. And then it's showing each of these answers has P and C separate, so what I'm going to do is factor out a -4 from all of those. Not all of those, just those 2, to get -4 times P plus C, and I'm going to divide by 9. I get 20 minus 4 over 9 P plus C equals F, which is, in fact, B. Another B answer. All right. Last one for this test is number 30. Great. All right, this one's a little confusing, so take your time reading it and trying to think how you would approach this one. It says the manager of an online news service received the report above on the number of subscriptions sold by the service. The manager estimated that the percent increase from 2012 to 2013 would be double the percent increase from 2013 to 2014. How many subscriptions did the manager expect would be sold in 2014? So we need to know the percent increase from 2012 to 2013. Okay, in order to do that, we can set it up with the final amount minus the initial amount over the initial amount. And whenever we're doing percent increase or decrease, the division is always based on the number that we're starting from. So 5,600 is what we're increasing to get to 5,880. So that's always the one we divide by. That's going to be 2,800 over 5,600. 28 over 56 is 1/2, and then we have another 0 in there, so this would be 1/20th, which is also 5%. Now he says he estimates that will be double the increase from 2013 to 2014. So this is twice as big as we need it to be for our next step. So the new percent increase is going to be 0.025, not percent, 2.5%. And that's just an increase on 5,880. So you can use your calculator and type in 1.025 times 5,880. Remember, we take 1, add the percent in decimal form, and that's representing a percent increase. And that's going to end up being 6027. All right. One more test down. All right, we're going to start on 13 for this one. Oil and gas production in a certain area dropped from 4 million barrels in 2000 to 1.9 million barrels in 2013. Assuming that the oil and gas production decreased at a constant rate, which of the following linear functions F best models the production in millions of barrels T years after the year 2000? All right, this constant rate, I mean, it says it later, but anytime you see constant rate, think linear function. So we're looking for something in the form of y equals mx plus b. And we see that we had 4 million barrels in 2000, and that's where we're starting at. So I know b is equal to 4, and that doesn't help us that much because that's the same in every answer. But now we're looking for a slope. So we can see that we have 2 values. We have the first one at a time of 0 years after 2000, and that's why it's t is 0. And I'm doing these in form of t comma f of t. We had 4, and then in 2013, which is 13 years after 2000, we had 1.9 barrels. And now we can find the slope, which is just change in y over change in x. So 1.9 minus 4 over 13 minus 0 equals negative 2.1 over 13. And we can see that that is not an answer, but it is very similar to this one. If we were to multiply the top and bottom by 10, it's essentially the same fraction. So this one is C. Just kind of focusing in on the important aspects of the problem. It's sometimes hard to recognize, but using, again, this slope-intercept form of a linear function is really helpful. Getting yourself what you know about it. You can use the answers sometimes for that, and then figuring out what you don't know. In that case, it would be the slope. All right, next one is we move to the calculator section of the same test, test number 8. And we're looking for question 27. That's 17. There we go. All right. In the xy plane, the point P, R lies on the line with equation y equals x plus b, where b is a constant. The point with coordinates 2p, 5r lies on the line with equation y equals 2x plus b. P does not equal 0. What is the value of r over p? All right. These problems that are asking you for a comparison of two variables means that we need to get those two variables alone in an equation and get them equal to some numbers. We can see it's some sort of fraction. So in order to at least get started, I'm going to take these points that were given and plug them into their equations. So r is y, so r, p is x, so r equals p plus b. And then we can do the same thing, 5r equals 2 times 2p, so 4p, also plus b. Rewrite that first one so it's actually legible. Great. Now there's this b that's in both of these equations, but luckily it's not that hard to get rid of it because we can just move the p's over and set them both equal to b. So if I subtract p in the first one, we get r minus p equals b, and 5r minus 4p equals b in that equation. And now we can set them equal to each other because we solved for the constant that was kind of the outlier, the thing that we didn't want in our equation, and now we can use that to combine these two variables into this expression that we're looking for. So r minus p equals 5r minus 4p, setting them equal to each other. And now we need to get r over p. So if we get them on opposite sides, we should be able to divide by p and get them get that expression that we're looking for. So subtract r from the left, add 4p from the right. So 3p equals 4r. And now if we divide the left or both sides by p and both sides by 4, we can see that we get r over p equals 3 over 4. All right. Next one is 29. All right, so a photocopy machine is initially loaded with 5,000 sheets of paper. The machine starts a large job and copies at a constant rate. After 20 minutes, it has used 30% of the paper, which is the following equation models the number of sheets of paper, p remaining in the machine, m minutes after the machine started printing. So we have this after 20 minutes, it has used 30% of the paper. So 30% has been used up, so that's a 30% decrease. So what we can do is 5,000 times, again, 1 minus 0.3, which is just times 0.7, equals the paper after 20 minutes. So 20, 5,000 times 0.7, you can use a calculator, but if we divide 5,000 by 10, we get 500. Multiply it by 7, we get 3,500. So that's the point that we have. Now it's tempting to see or think that we can use this function, right? Because after 20 minutes, we're going to get 5,000 times 0.7, which is what we just did in order to solve for this one point. However, copier copies at a constant rate. Is a sneaky but very important distinction from this equation that we're given. This is an exponential decay function, which does not represent a constant rate. Even though that point does work, we need to use this point and our initial point of 0, 5,000 in order to find the constant rate slope. I kind of hinted at that earlier, that if we see constant rate, it's going to be linear. And in this case, we're going to do the same thing to find our slope, change in y over change in x, 5,000 minus 3,500 over 0 minus 20, 1,500 over negative 20, which equals negative 75. And so that, with 5,000 being our y-intercept, negative 75 being our slope, that is the function that describes it for all m, and not just m being 20. All right. Test 9, no calculator, number 15. What is the set of all solutions to the equation square root of x plus 2 equals negative x? Now, they've introduced these types of problems in test 9 and 10. And they're trying to trip you up, is all I'm going to say. Because if we were to solve this algebraically, x plus 2 equals negative x, square both sides, x plus 2 equals x squared, move it over, set it equal to 0, we would get x minus 2, x plus 1, so we would get x equals 2 comma negative 1. And then you could look for outliers, right? You could say, we can plug it back in and check to see if one of them doesn't work. But technically, the square root of 4 does equal plus or minus 2. But the answer to this one is just negative 1. And I think the best way to think about this is to think about it graphically. If we were to plot both of these functions, we would get negative x, y equals negative x, and y equals the square root of x plus 2. We're to plot both of those and solve for their intersection points. Square root of x plus 2 just looks like that. It does not have this secondary piece below it, which is where we're getting that x equals 2. We would just get negative 1. So algebraically, you can get these two values, and some people might think that it makes sense, but if on these SAT questions they're looking for the deliberate square root, which is just going to be the positive answer, and so in this case we are just going to use the one that in the function actually does intersect, and in this case it's just negative 1. X equals negative 1. So just be careful for those. I've seen them, they've come up on both tests that they've added in, so I think that's going to be something that they're going to be putting into most future SATs. All right, now the calculator section, we have this set of questions, 18 to 20, I think are pretty challenging. Jennifer bought a box of Crunchy Grain cereal. The nutrition facts on the box state that a serving size of the cereal is 3/4 cup and provides 210 calories, 50 of which are calories from fat. In addition, each serving of the cereal provides 180 milligrams of potassium, which is 5% of the daily allowance for adults. All right. If P% of an adult's daily allowance of potassium is provided by X servings of Crunchy Grain cereal per day, which of the following expresses P in terms of X? So we're dealing with X servings and P%. Now it tells us that X servings gives us 5% of the daily allowance. And so if we had one serving, that should equal 5%. And if we had two servings, that should equal 10%. And so it is a linear equation, so it doesn't make any sense for it to be D or C. In this one, because we're dealing in p%, it's not actually going to end up being 0.05, it's going to end up being just 5x. This one's a little confusing, but again, we have to remember that p% is being represented by dividing it by 100. And so in this case, it is just the true percentage that after one serving we'll have 5 will be equal to p, and that is the actual percent value. Number 19, on Tuesday, Jennifer will mix crunchy grain cereal with super grain cereal for her breakfast. A lot of grain. Super grain cereal provides 240 calories per cup. If the total number of calories in 1 cup of her mixture is 270, how much super grain cereal is in 1 cup of the mixture? Now this is a pretty evident system of equations. I'm going to set up x as crunchy grain and y as super grain. Now I know that the total is 1 cup, and this is in cups, just to be clear. I didn't use my brackets like I normally do, but there you go. The unit is cups. X plus y has to equal 1 cup, and then before you go and throw in 210 for multiplying by x to get the calories per cup, we have to realize that that serving is dealing in 3/4 of a cup. So we have to say 3/4 is to 210, like 1 is to, and in order to get to 1, we would multiply both sides by 4/3, and that would be 280. So 1 cup is 280 calories. And so we get 280 times x, not 210, plus 240, y equals 270. And this is in the calories of the of her cup of a mixture. So again, the first one is cups, second one is in calories for the units of our equations, which I think can be helpful with setting those up sometimes, is thinking about what units you're dealing with. And now we need to solve this. So I'm going to multiply, and we care about super grain, but I think it's easier to deal with the get rid of the y's first. So I'm just going to multiply by negative 240. Rewrite it up here. Add them together. Those cancel. We get 40x equals 30. And so x equals 3/4 of a cup. They needed to add to 1, so this one has to be 1/4 of a cup. And remember, we're looking for y because it's the super grain. How much super grain in cups is in there. All right. Number 20, which of the following could be the graph of the number of calories from fat in crunchy grain cereal as a function of the number of 3/4 cup servings of the cereal. So if we look back up at the top, calories from fat was, I think, 50, which is linear. So it should be an increasing linear function, slope of 50. And so it can't be C or D, because obviously if you have a million 3/4 cup servings, you're not going to only have 50 calories from fat. It's not going to be the same. It's also definitely not going to get less the more cups you have. So the question is it A or B? Now if you have 0 3/4 cup servings, you're also not going to get any fat or calories from fat from eating 0. So we should start at the origin, 0, 0, and this one is going to be A. So that's a little bit of just graph analysis. Not too difficult, but I wanted to finish out the full set. All right, last test. Woo! Let's do it. Question 19. Based on the system of equations above, what is the value of 5x plus 5y? Now you see it is a system, so your first instinct might be to solve for x and solve for y, but if you just add these two functions together, we end up getting 5x plus 5y equals 2500. And that's what we're looking for. So it's not necessarily a tough question, but I think if you're taking the SAT and you're practicing or you're studying for it and you're doing a bunch of these problems, look for these things in there. They can be hard to notice at first, but once you start noticing them, they make the problems a lot easier that have these kind of shortcuts in them, and it requires a lot less math and a lot less time that you could be spending on other questions. So 2,500. In the similar vein, we're going to do number 20, where we have u plus t equals 5 and u minus t equals 2. What is the value of u minus t times u squared minus t squared? Now you could solve for u and you could solve for t, and you could do all this squaring and addition. I believe there's some fractions in there, so that wouldn't be too fun. What we can also do is rewrite this difference of squares of u squared minus t squared as u minus t times u plus t, and just evaluate that, because we already know what all of these are equal to. U minus t is 2 times 2, u plus t is 5, and that's just 20. Again, these are definitely not as hard as the previous questions we've been doing, but they can be done in kind of tricky ways, or at least different ways than going through the whole process, and I highly recommend getting good at that. It'll save you a lot of time, so you can do the actually difficult problems, or just the wordy ones that take a little bit longer and don't have little shortcuts in them. All right, calculator portion. All right, number 16, next on the list. In 2015, the populations of city X and city Y were equal. From 2010 to 2015, the population of city X increased by 20%, and the population of city Y decreased by 10%. If the population of city X was 120,000 in 2010, what was the population of city Y in 2010? So we know they were equal in 2015, so that's important. And then there were some increases, and we're given one value. Can be a lot to keep track of, so what I'm going to do is just make a little table. I'm going to say we have X, Y, 2010, and 2015. The only value we're given is city X was 120,000 in 2010. And we know that was increased by 20%. So again, whoops, ignore that. Increased by 20%. That's just multiplying by 1.2. 0.2 of 120,000 is 24,000, so that's going to end up being 144,000. We know that it's the same for city Y in 2015, but it also says that it was decreased by 10% from 2010 to 2015, so we can represent that by saying city Y in 2010 times 0.9, which is a decrease of 10%, is equal to 144,000. So you can use your calculator and divide 144,000 by 0.9. If you divide it by 0.9 and multiply it by, or 9/10, so divided by 9, multiply by 10, you're going to end up getting 160,000. All right, last and certainly not least, we have number 23. Great. We have a nice little table here, and then some values of x and their corresponding values of y are shown in the table above, where a is a constant. If there's a linear relationship between x and y, which of the following equation represents the relationship? All right, we have a linear relationship, so I'm going to try and get it in y equals mx plus b form, and then move it around so that it looks like one of these answers. So the slope, we have a number of points to choose from. I'm going to pick the first two and do change in y. 0 minus negative a is just 0 plus a over change in x, a minus 3a equals a over negative 2a, which equals negative 1/2. These cancel. So our slope is negative 1/2. So y equals -1/2 x plus b. Now to solve for b, I'm just going to pick one of the points and solve for b. And it's going to end up being in terms of a, but all the answers have a in them, so that's going to make sense. Choose this first point again. I'm going to try and make it as easy on myself as possible. -1/2 a plus b. So 1/2 a equals b. So 1/2 a equals b. Great. And now we can rewrite our standard linear function with actual values. A, and multiply both sides by 2 to get rid of these fractions, and then move x over to the other side. We can see that we end up with x plus 2y equals a. All right, and that is, in my opinion, the hardest questions, 28 hardest questions in the 8 online SAT practice tests. Thank you for watching. If you thought this was helpful, leave a like. Comment on the video with any questions that you thought were hard, maybe some ideas for future videos. Just getting started doing this. Hopefully I'm going to move into both reading and writing, as well as some ACT help, and maybe some more SAT math on some of the more common questions that aren't this difficult, and how to do those. Thanks for watching. See you next time.